So I'm going to explain about the first chapter, that is chemical reactions and equations. So first I'm going to explain about what is chemical reaction. So children, chemical reaction is nothing but some change as a result of which new substance or new substances are formed on mixing or bringing together a substance or variety of substances under proper conditions. So proper conditions have to be there. Suppose we say on heating limestone we get calcium oxide and carbon dioxide. So it is chemical reaction. It is chemical reaction. Limestone on heating forms quicklime and carbon dioxide. Similarly, we say when we burn hydrogen and oxygen, there is formation of water. Or in the electric spark, there is the formation of water. So this is the meaning of chemical reaction. Now coming to chemical equation. So chemical equation is nothing but the symbolic representation. Symbolic representation of any chemical change, any chemical reaction. We use the symbols. We use the symbols of different elements and different formulas. Like in the first, this CaCO3, it is limestone. This on heating, there is formation of calcium oxide and CO2. This is quicklime. This is said to be quicklime. So this is chemical equation. So what is the benefit of writing the chemical equation? Chemical equation saves our time. Chemical equation saves our time, labor, and moreover it is a smart way. It is smart. So there are three benefits of writing chemical equation. It saves our time, it saves our labor, and we can write in a smart manner of any chemical change. Now, other point is the identification of chemical change. Identification of chemical change means how we are able to understand a chemical reaction has taken place. Chemical reaction has taken place. So, first point is formation of what? New substance or substance. This is one. New substance. It is one. It will decompose to form the new substances. If we take other case like S2 and O2 in electric spark or burning, there is formation of water vapor. So chemical reaction and physical reaction, chemical change and physical change can be identified by formation of new substance or new substances. Then liberation of gases in large number of gases. Gases are liberated. Gases produce large number of gases. Most of, not all, but a large number of gases. Then there can be absorption, maybe absorption or release of heat. Then there can be change in a state of reactant or reactants pigment. So this is about the identification of the chemical change. Or now coming to the type of equation. So chemical equations are of two types. First is skeletal or unbalanced. Skeletal or unbalanced equation. Skeletal or unbalanced. So skeletal is also called as unbalanced. An equation is said to be unbalanced when the number of atoms in reactant side and product side, they are not same. Like H2 plus O2, it gives rise to H2. Hydrogen at decline, 2. Oxygen, 2. Hydrogen, 2. Oxygen, 1. So that's why we say that this equation is unbalanced. And it is also called a skeleton. A skeleton means the basic structure. Now the second is balanced equation. So as same, just opposite this equation is said to be balanced when the number of atoms are found to be same on the two sides of arrow mark. So here H2 plus O2 gives rise to H2. This is unbalanced. So we put here with 2. So here it is 1, so we have to balance it. So now in this condition oxygen has been balanced, but here hydrogen is not balanced. So simply put here. So here hydrogen is equal to 4, oxygen is equal to 2, hydrogen is equal to 4, oxygen is equal to 2. So this is the way of balancing. So children, then I am coming to the balancing of equation. So balancing of chemical equation is based on the heat and trial method. It is based on heat and trial method. Heat and trial method. Heat means we strike, just by striking. So basically in heat and trial method there is no rule. There is no rule for balancing equation. Simply we try again and again, and we put the suitable integer, we put the suitable coefficient. But in any case, the coefficient should not be written here, that is in the right side or in between. In all the cases, it is mandatory, or it is only one condition. It has to be written only to the left side. So it can neither be written on the in between the different elements or not right to the molecule or right to the species. Only and only left side. So simply we count. We count like this. Again, CaCO3 on heating it forms COO plus CO2. How to start balancing? So counting is important. So calcium is equal to 1, then coming to carbon is equal to 1, and then oxygen is equal to 3. On this side, calcium is equal to 1, oxygen is equal to 1 plus 2 is equal to 3, carbon is equal to 1. So we compare. Calcium is equal to calcium, carbon is equal to carbon, oxygen is equal to. So simply we have to write down, and he write equation is already balanced. So simply this is nothing. There is no rule. There is no any specific condition. Actually, in class 10th we use hit and trial method, but in class 11 there are some other methods also. Oxidation number method, partial equation method, but it is only, they are highly complex. But this method is applicable everywhere, in all the classes, 10th, 11th, 12th. There are some conditions for that oxidation number method and half equation method in class 11th, but it is very much important to understand about the balancing. Now coming to The classification of reactions. The type of reactions. So reactions are of different types. First is combination reaction. So combination means the reactions in which smaller molecules or atoms are added to form the bigger molecules. Under proper conditions have to be there, like H2 plus Cl2 in presence of sunlight. In presence of sunlight, there is the HCl. Similarly, CaO, quicklime, when added in water, there is formation of calcium hydroxide. This calcium hydroxide, it is called as slaked lime. So children have to keep in mind the names because they are very much important to recall. So we have three things. Limestone is CaCO3, quicklime is calcium oxide, slaked lime is calcium hydroxide. So other question. Why calcium hydroxide is called as slaked lime? Who will answer? Calcium hydroxide is called as slaked lime. What does it mean? Calcium hydroxide is called as, I have explained so many times in classes. Come on, very simple question. A smart question. No chemistry. Only general awareness is required. Slake is English word. So, what is the meaning? Slaked lime. No idea? Rahul?
सर ये H2O वाटर में डाल के मिलाते तो
I want to know what is the reason why it is called as slaked lime.
सही होता है.
Tanya? No idea? Actually, slaked means, slacking means to settle down. Slacking on, or it has slacked. When anything goes inside, sink inside, it is called as slacking. Like, calcium oxide, quicklime. You must have seen it is solid. It is solid. It is just like a stone, very hard stone. When we keep in water, it settles down. It slacks away. That's what is called as slaked lime. Very simple. Slacking means settling down. Now, second is decomposition reaction. So, decomposition reaction means to break. Breaking of the molecule. So here, bigger molecules. So decomposition reaction can be defined as a reaction in which the bigger molecules are broken down into smaller ones. Bigger is broken down into the smaller ones. So it is of three types: thermal, electrical, and photochemical. Thermal, as the name indicates, by heat. It is by heat, by current, by light or sunlight. No need of sunlight. You must be knowing the photo cameras. In photo cameras, earlier on, nowadays there is a digital camera. Earlier on, still it is on. There are the reels of the photo camera. Photographic reels were there. And it was processed only in the dark. Still the persons who are processing, all the studio persons, they were having the dark room. room completely dark, because the roads they were exposed. Even by chance, entire road was destroyed, discarded by sunlight, because the photosensitive materials are made up of silver salt, and all the silver salts are sensitive to light. So, thermal decomposition, any reaction, like we take the case of zinc carbonate. Zinc carbonate on heating, it is converted to zinc oxide plus CO2. So, any reaction, you should not write water. Water will not decompose on heating. It is very decomposed by passing current. Because in case of water, the force is very much stronger between hydrogen and oxygen. Now, electrical decomposition, we take the water. So, water must be acidic, and on passing current, there is S2 and O2. So, here we balance. So, this oxygen is produced at anode, and this is produced at cathode. Yesterday there was a question from that why in the book the ratio is double, its ratio is half. So because in water there is a ratio of 2:1. So in electrolysis, the amount of gas collected, if the test tubes are of same dimension, keep in mind, then hydrogen will be double, oxygen will be half. And so, similarly, you can take any other example, like NaCl, molten. On passing current, there will be sodium solid, chlorine gas. So this will be at the anode, sodium will be at the cathode. So chlorine gas is at the anode, it is at the cathode. Now coming to next, photochemicals. So photochemical reactions are those reactions which take place in presence of sunlight. So sunlight. So example, all the salts of silver, they are sensitive to light, like silver bromide, silver iodide, silver nitrate, etc. All decompose in presence of sunlight. There is no requirement of any strong light, just in tube background. So, silver bromide solid, it is colorless, and in presence of sunlight, there is silver. This gas here, gray solid is often. So decomposition reactions are just opposite of the addition reactions. They are just opposite of the addition reactions. And we say, explain why decomposition and addition reactions or combination reactions, they are opposite to each other. So it is because in case of addition reactions, heat is released generally. In case of decomposition, energy of heat is required. Now third is displacement reactions. Displacement reactions. So displacement reactions are those reactions in which less reactive element is displaced by more reactive. So more reactive element displaces less reactive. It is of two types. single displacement and double displacement. A single means one species. Like if you put iron nail in copper sulfate solution, so it has blue color, and there is solution of F-sulfur aqueous, it has light green color, and there is copper solid on the iron nail. So the position of copper on the iron nail. So this is displaced. Just we go like this. Here we keep the iron nail, and so this is the brown color. This solution is become light green. It is light green. So this is single displacement reaction. Now in case of double displacement reaction, two species are mutually displaced. They displace each other. Like we take the Na2SO4 sodium sulfate aqueous plus BaCl2 aqueous. Both are colorless. On mixing, we get BaSO4 solid, and it is white PBT plus 2NaCl aqueous, it is colorless. And so we represent like this. Initially, on mixing the two solutions, they will be colorless. But as soon as we mix, it becomes milky. We allow to stand. After some time, in the lower portion, it becomes what? It becomes white PBT, and this is colorless solution. So this is precipitation reaction. And this is called as precipitate. So precipitate is always insoluble. It is always insoluble